Let's start this course off by exploring Python. I recommend that if you're going to follow along with any of this, you create a folder to work within. And first of all, what we're going to check is that you have Python installed on your machine. We can do this by running the command python3 -- version. This will tell us that we have Python 3.10.8 on my local machine. That means that I know I can create whatever Python script I would like because the Python interpreter exists on this machine. So let's jump straight in. You can use whatever editor you choose to use. I'm going to use Nano, and I'm going to create demo.py. What we're going to first do is we're going to put what is called a shebang. This is the hash symbol followed by an exclamation point, and then bin python3. Now what this does, it's good practice to have this at the top of any script you create. It tells the computer what kind of script this is. So should we later on choose to run this by executing /demo.py, our computer will understand that this is Python, and it will actually run the command python3 demo.py. During this course, we're just going to define this when we want to execute it by using python3 demo.py. So what can we do with a Python script? First, we're going to explore strings and integers. So let's put a hash symbol to comment out the word strings so that we know everything below this is to do with a string. That hash symbol means that when the program executes, it will not do anything with any of the text that follows that. So a string is a traditional sequence of characters. Essentially, a string can be any series of characters that you want to have in your code or in a variable or as part of a command. We're going to just run the inbuilt print function that Python has. It's called print. And we're going to use hello world as the nice traditional first print command that people try when learning new languages. What this will do is it will print out the text hello world into our terminal when we execute this. So let's take a look at that. Let's close this down. Python3 demo.py, and we can see hello world is displayed in the terminal. If we go back to our editor, we can explore how print can work with strings. We don't always have to use double quotes. Hello world is absolutely fine in single quotes, and we can have text that runs across multiple lines if we use the triple quotation. So we can do hello world here. If we execute this, we can see that each one of these lines printed to the terminal because they are all defined as strings that are within the print function. If we think about the fact that we may not always be wanting to use text in our programs, and instead we may be wanting to use numbers, we can explore how numbers can work within Python as well. Now, Python is very good at being able to do mathematics inbuilt as part of its processing. And if we explore this to demonstrate it, we can have a look at the print command again and do some simple maths like 2 + 2, 2 take away 2. We can see here that at the end we have 4 and 0, the answers of 2 + 2 and 2 take away 2. Let's jump back into our program. We can explore also 2 times 2 and 2 take away 2. Divide 2, sorry. And we can use this to start to increase the complexity of the mathematical functions that we use. When we execute this, we can see that 2 times 2 again resulted in 4, whereas 2 divided by 2 resulted in 1.0. This is a key concept within program of the difference between integers and floats. Essentially, an integer is a whole number. We have used the integer of 2 and added, taken away, or times the integer of 2, and the result of that equation is a whole number of either 4 or 0. Because these are whole numbers, they are integers as well. When we've done 2 divided by 2, what we have is the result called a float. A float is a number that is not an integer. It is a number that has a decimal point. As you go through learning more about programming and as you create more and more complex code, floats can be very important to work with to make sure that you are getting a level of accuracy that you just don't get when it comes to integers working on their whole number basis. So, this is a simple introduction of how we can have numbers and text in a Python script. In our next module, we're going to have a look at how we can introduce variables into both of these different types of parameters. Now that we've explored integers and strings and how we can incorporate those into our scripts, let's look at something a bit more interesting. Let's take a look at how we can explore variables. Variables, as the name indicates, are small areas of memory that are able to hold data for use later in our script. Essentially, this allows us to create a value that can be called anywhere within our Python script. So let's create demo 2. We're going to put our shebang at the top and put a comment of the word variable so that later on when we look at this we can see this is the topic being explored. Prior to this video we have introduced basic mathematical equations by hard coding values into our Python script. Let's explore how we can do the same thing but with variables instead. So if I type x equals 2 and y equals 4, our script will now understand the variable x and y to be assigned the appropriate integer values. It's really important to be aware that Python is smart enough to understand that these are assigned integers because there are no quotation marks. If we were to type z equals quote 6 quote, we can see the color changes, and this is to denote that the value of z is a string, not an integer. So let's take a look at what happens when we execute this script. We're just going to quickly delete z, exit out of this, and then use Python 3 demo2.py. We can see that nothing happens when we execute it, but that's fine because there were no print commands. So let's go back into our script and we will type a print command using some of the same examples we've previously done. So let's do print x plus y. That will do, we'll print x and y first. Then print x plus y, let's do print y minus x, and now let's print x multiplied by y. We can run this and see the output for each of those equations because our script understands the value of x and y variables and is able to output the result of those equations. So let's neaten up this script and get rid of these print commands. We're able to output these variables into a text output, so into a string format, but we must be aware that when outputting into a string format, that integers cannot be dropped straight into that print command. So let's create a print command using strings. We're going to open our quotes, type x equals 2, y equals 4, therefore x times y equals, and I can't just put the output of x times y here because we're inside the quotes of a string, so we need to close this off, and then we need to do a plus and use the str to convert the output of x times y into a string format, and then close my brackets off. This is because we are merging two different data types into one print output. That's why we need this string command in front of x times y. So it's really important to be aware of that. So when we execute that, we can see that the mathematical equations are still executed by our script. So this is a really simple demonstration of how we can hardcode variables into our script and how we can show them being printed and merge two different data types, strings and integers, into one print output command. So if we don't know the current value of our variables, we can still run this same kind of command. We just need to use a slightly different print command. So if we type print and x equals, then we're going to close down this string and put the parameter x inside these brackets. We're then going to open up the quotes and put y equals, and then we're going to need to close these quotes again in a second, and do the plus symbol and string the value of y. It's really important when observing this that we're spotting the spaces I'm putting in here. So this, therefore, x plus y equals space, close brackets, and plus string y times x. This means that when we close out of this and execute demo 2, that we will still have the correct syntax, because within my quotation marks I've put spaces. So we can see this is output to the terminal, x equals 2, y equals 4, therefore x times y equals 8, all with the appropriate spacing. Now that's all well and good when we're working with static variables, but what happens when we want to change the values? Potentially we've got a situation where we want to increment x by typing x equals x plus 1. This means that we're going to add 1 to the value of x, and we're going to print out the parameter x. So if we type open quote x equals close quote plus the string value of x, when we now execute this, we will see that x is now equal to 3. We can also go back and type x plus equals 1. This again means that we'd like to increment by 1. And if I type another print statement to show this has worked, we will be able to see, when I execute this, that x is now equal to 4. What's important to be aware of is if I now type something like print x times y, the latest value of these variables will be used. So if we drop back and execute this one more time, we can see that x is now equal to 4. So when we're doing x times y on this final line of print x times y, we're actually running print 4 times 4. It doesn't matter what the original value of the variable was, we've made modifications to it, and now when we're calling this print statement here, it's x times y at the bottom, we're getting our new variable values. Let's explore how we can also have variables that are strings instead of just integer values. So if I declare a new variable, I'm going to come down here, I'm going to type name equals, I'm going to open quotation marks and type Dan, close quotation marks. We can again see the color changes denoting that this is now a string value. I can still type print and the name of my variable, and we can see that Dan is now output when we execute that. So if we come back here, what we can do is we can create a new variable called language equals Python, and we can have a similar example where we pull in these two variables into one print output. So we'll type print, open brackets, open quote, my name is, we'll have to close the brackets and do the add to add our variable. So we're going to add name, then we're going to add a new string, open quotes, I am learning, we're going to have to close the quotes again, plus language, and then close off the brackets. When we execute this, we can see we get this, my name is Dan, I am learning Python. So we can see it's a really simple way of being able to execute that. And that was historically a common way of doing this. However, since Python 3.6, there has been the introduction of something called F strings. Now, F strings are formatted strings, and they make this kind of thing much easier to type and much easier to read. This means that we don't have to constantly close these quotation marks, type plus, and the name of a variable. So if we want to use an F string, what we have to do is quite simple. We just need to type a new print command, then F, open quotes, and our string. So I can type my name is, and instead of closing the quote, I'm going to open a brace, use my variable name, and close the brace. So this will be my name is Dan. I don't have to do anything other than continue my string for I am learning, open a brace, language, close brace, close the quote, close the brackets. This will now use those variables, and we can see my name is Dan, I am learning Python, printed out again in our output. And this doesn't have to just be string values. We can use F strings to have any kind of variable in there. So we can create a print statement. I'm going to use this F, open quotes, I'm going to type my name is, we're going to use that name variable surrounded by those braces. I have set X to, and then I open a brace and give my parameter name, that variable name again. So X and Y to, open the brace, Y, close the brace, and can multiply them together this way in a really simple way. So, and can multiply them together to get open brace, X times Y, close brace. We've got to close off the string with the quotation, close off the print with the bracket. And now, if I execute this, we can see my name is Dan, I have set X to 4 and Y to 4 and can multiply them together to get 16. Remember, those values have changed from when we originally had X equals 2, so they're using the latest value of each of those parameters. just going to put a comment in here to make clear that these are F strings, and the syntax is just a little bit clearer when we're trying to output parameter values into a string. So that's how we can use variables. F strings make that nice and easy. It needs Python 3.6. Now that we've become familiar with different data types and variables that can be used as part of our script, we're going to explore functions. Functions are small segments of our code which are responsible for conducting some form of action or processing of data. Essentially, a function is a small piece of code within our script that we can then call to execute the action defined within itself. So let's create demo3.py. We're going to put our shebang in here again, and we're going to have a comment of function with no parameter. This means that we will have a function that we do not have to provide some form of variable or data to. So to establish a function, first of all, we have to define the function itself. So I'm going to have define function 1. Now, typically in a proper script, your functions will have some form of logical naming convention that makes sense to you. It's commonplace to have these be descriptive of what the function is achieving so that you know what's going on. This has defined function 1 as existing, and throughout this video we're going to stick with just function 1, function 2, function 3, etc. But when creating your own scripts, I highly recommend coming up with an actual descriptive name. So let's jump straight into our function. We've worked on a lot of mathematical calculations as demonstrations of how Python can be used, so we'll stick with that and define variables and a calculation to occur. We're going to hit tab, and that's because we need Python to understand that all these subsequent lines of text that we put here are part of this function. So I'm going to declare my variables of x equals 2 and y equals 4. You'll remember that because Python is reasonably intelligent, it will understand that these are integer variables now. And then I'm going to run a print command that will just multiply those variables together. That is our function in essence. It will define the variables and it will conduct an activity. If I now type function 1, what our script will now do is define a function and then execute that function. So if we run demo3 at this point, we can see that the calculation has occurred. X is 2, y equals 4, both of them multiplied together is 8, and we get that on the screen thanks to our print command. So that's relatively simplistic. It's a function with no parameter, no ability for us to input anything of any real value here. What happens if we have a function that will take a parameter? So let's have function with one parameter. We can define the function, define function 2, and I'm going to have this as a string-based function. We've used function 1 as integers and calculations. I'm going to demonstrate that functions can work with strings as well. There is no restriction on what kind of activity you can have as part of your function. So let's have function 2 with the parameter of name that needs to be provided. We're going to use our tab again. It's going to make sure that Python understands this is part of the function. And this is again just going to be a nice simple print. We're going to use our f string again to make this nice and easy for us. Hello, name. You are learning Python. And then when we run this, we're going to provide the command to run function 2, and we're going to give it the parameter that we would like it to use, so Dan. Remember, these quotation marks mean that Python will understand this to be a string value. So let's see what happens when we execute this now. Python 3, demo3.py. Function 1 has been executed again. It's part of our code. It's gone through, it's done our mathematical calculation. We've then gone down to function 2, which is our printing of an F string, and it has taken the parameter that we have provided of the name Dan, and it has input that into the string that we are having output to the terminal. So, hello Dan, you are learning Python. So that's a nice simple way that we can see that we're able to have functions with no parameters and functions with a parameter. What happens if we want a function with more than that? What happens if we want to be able to do something much more interesting and have functions that are going to be more involved and more detailed in our script? First of all, let's take a look at functions with 2 parameters. We're going to define function 3. And this time, for ease, let's again just go back to integers. I'm going to have x and y. So our function will be expecting 2 parameters of x and y. We are therefore going to turn around and say what we would like this function to do. Remember, the tab is important. Print, let's just do x plus y this time. And then when we have function 3 running, we can turn around and provide the variable values for x and y. Let's have this as something different from x and y at the top, so you can see that these will take the new values. So let's do 6 and 8. If we run that again, we can see that function 1 once again has been executed, function 2 has been executed, function 3 has been executed. So this is a really nice, easy way to understand how we can just progressively have more and more mature functions. What we can also do is have functions that are doing different, more complex actions within them. So if we have a think about something more along the lines of a nested function, if we define function 4 as something where we are going to provide an integer and a string, so these functions don't have to just have one type of input, they can have whatever kind of input you want. What we can do is we can turn around and say, well, I would like to have some kind of action happen when I run this function. I'm going to have my tab and define what's going on. I can use the return command and say I want x times name. Now return is an interesting keyword because what happens here is that the process will occur. X times name will happen, but we're not using print here. So we're not going to see anything particularly happen when we put this in our terminal and when we execute demo3.py. So if we take the command function 4, as we have with all the above, open our brackets and provide the variables. We're giving it the 2 inputs that it needs. X is 3, name is Dan, and we are going to run this. You can see that there is no output here. That's because when we look at the output, it's done everything that it should do. It has printed the output for function 1, printed the output for function 2, and printed the output for function 3. Each of these have the print commands that you'll see as we scroll through. Here is our print command for function 1, here is our print command for function 2, here is our print command for function 3. When we're looking at function 4, there is no print command. This is just, at the moment, it's a single function that is returning data to the script but not doing anything. When I say nested functions, what I mean is that we can use the print function itself to say that I would like to run the print function that is a known function within Python. That is what print is doing. It is a function within itself that will output to the terminal. And I would like print to display whatever the output of function 4 is to my terminal screen. So the function itself does not have any output, but I can provide the command to tell Python that while you may not have the command to output function 4 to the terminal, I would like you to do that anyway. So let's have a look at what that would look like. Now we suddenly get an output to function 4 because we have turned around and used our print function to say I would like you to print whatever function 4 is doing. Let's take another quick look at that. This is our function 4. There is no output command here. It is just a command to take one parameter and paste it 3 times. We're just turning around and saying, if x is 3 and name is Dan, then function 4 is equal to Dan, Dan, Dan. It is only when we turn around and say, I would like to use the print function, that I can then define within those brackets. Remember, we can see print always has whatever it is printing in brackets, that I can turn around and say, within my brackets for print, I want you to run the command function 4 with these variable values. So hopefully you can see that different functions can achieve different goals, and they can get complex, they can be simple. There's a lot we can do with the different functions that we can write, and we can have them be tools that provide output to the terminal, or we can have them just be parts of code that will have information in memory ready to be called upon or ready to be processed when we want that to happen. Next, we're going to look at loops and how we can incorporate that as part of our script. Let's add a new feature to our Python scripting. Let's talk about loops and how they can be applied to our Python script in a useful way. Loops can be incredibly helpful as it allows us to undertake the same actions while some form of validation is being undertaken. No, I don't know that at all. Let's take a look at a new feature of Python, and let's talk about loops and how they can be applied as part of our Python script in a useful way. The main goal of a loop is to be able to undertake the same action while some form of statement or some form of requirement is in effect. There are multiple different ways of conducting loops, and we're going to explore for loops and while loops. So let's create demo4.py. Put that shebang in there. And we're going to put a comment here to say we're going to look at a basic for loop. Now what we can do for a for loop is that we can say something along the lines of for x, so parameter, in, and then give it our parameter here. For x in North Green, do something. So the formatting of this is very similar to a function where we've got to remember our tab. What this is essentially going to do is iterate through the sequence of this parameter of North Green. So if I say for x in North Green, print x, then what will happen is Python will take North Green as its variable, as its parameter value, and it will print every character in this word in an iterative sequence. So let's see what that looks like. You can see that there we go. We have North Green printed out one character at a time, because we're saying here is a variable, here's a parameter, here is our input, North Green. I want to run a for loop to say that you should print out every character as the value of X. So that's a very basic loop. What happens if we don't want to give it something like just a clear string or a value in such a simplistic way, but instead we want it to loop through a list? Well, let's define what our list will be. First of all, put a comment here to say basic for loop with a list. Let's use days of the week as a nice simple concept. We can define our list. Wednesday, Thursday, Friday. Let's just go for the work week. We've defined the value of the days variable as this list of the work week: Monday, Tuesday, Wednesday, Thursday, and Friday. Python understands these to be string values because they're in quotation marks, and we can see that in the color notation as well. So what I can do is I can now say for X in days, my indent, again, that tab, to say this is what I want to happen within this loop, print X. And we'll see what happens here. And there we have it. We have our original simplistic North Green, that's being pasted out, and now we have our list that is being pasted to the terminal, printed to that terminal one at a time throughout that list. Really simple as a way of being able to iterate through that sequence, whether or not it's a string, whether or not it's a list, whatever it may be. This is a for loop. You are turning around and saying, I'm going to give you something, and you're going to loop through it. Now, this only includes the for command of saying, while this is in effect, while you have values within this list or string, I want you to print. What happens if we introduce the else command? Else is a command that we can use when we want to turn around and say, we've got out of the loop, we've completed this loop, and something has happened, something that does not quite adhere to this loop is going on. So if we turn around and say that I'm going to take that exact same command, and I'm going to say, here's my weekdays, print each day. What I'm going to do is say else. So if we get to the point where X is now outside of this list, so it's gone through Monday through Friday, what I want it to do is print it's the weekend. Now hopefully you can see the logic here. What's going to happen is X is going to iterate through my list, and it's going to say Monday, Tuesday, Wednesday, Thursday, Friday. It's going to get to the end of the list, at which point the for loop has been completed. So we move to the else statement, where it will then turn around and say, well, we're no longer within the loop, so I should now print it's the weekend. Let's watch. So we can see, here's our North Green, here's our simple list, Monday through Friday, and here's our for loop with an else statement, it's the weekend, at the bottom here. Now this is obviously relatively trivial as a demonstration of how you can use a looping feature. Let's explore something that can be much more useful in an advanced script that you might come up with, and let's look at nested loops. So a nested loop is where we turn around and say, I would like you to loop through a string, a list, whatever it is I'm providing you, and when you go through each of those values, I want you to then do a subsequent loop of something else. So if I write this out so you can see it, let's have days of the week again, and we're going to, this time let's just have the shorthand. Monday, Tuesday, Wednesday, Thursday, Friday. Close that list off. And I'm going to include meals here. Meals equals, and here's my secondary list. Breakfast, lunch, dinner. I now have two lists that I can work through. Now if I suggest that I want to run a for loop, I could say for x in days. So it's going to take this list of days and it's going to iterate through each value. So it's going to iterate from Monday to Friday. What I want to happen is I want to say that in each of those instances, I'm going to use my tab to make sure I'm within my loop. I want you to actually run a secondary nested for loop. And I want to say for y, it's important that we have different variable values for the different loops so that nothing gets confused. So for y in meals, again, same syntax, that for with the colon at the end. I then need to set what I want to happen here. Print, let's just do x, y. Print out the value of x followed by the value of y. Now a really important thing here is to note the indentation. We have, same as every other loop, we have our for, and then we are indenting to say what we want to happen within that for loop. Because we are nesting loops, what's going to happen is within our for x in days loop, we're going to initialize a y in meals loop, which means that the print statement needs to have that double tab. It needs to be within that for y in meals loop. Otherwise, it won't work. It's not going to be understood to be part of the secondary nested loop. Indentation is really important. So let's save that and take a look at what happens. So what we can see is we've got, it's the weekend, about halfway down the terminal. That was the else statement from our previous for loop. And now we can see we've got Monday, breakfast, Monday, lunch, Monday, dinner, Tuesday, breakfast, Tuesday, lunch, Tuesday, dinner. What has happened is that the variable x in days has gone through its sequence and the nested y in meals loop has occurred each time. So if we just go back to our code quickly, we can see that our outside loop of x in days goes to its first value of Monday, and then we go through the subsequent loop, y in meals. We go through the entirety of that, breakfast, lunch, dinner. That completes, it's really important to note, that loop finishes before we then go back up to the x in days loop and move on to Tuesday. Drop back down to that y in meals loop and run the print command. Once that's completed, again, the 3 iterations of breakfast, lunch, and dinner, we go back up to the x in days loop and move on to Wednesday. This is how nested loops are working. The bottom loop, the furthest down loop, is the one that has to complete, and then you move up to the one above. Now, you can go incredibly complicated and nest loops within loops within loops within loops, but I'd highly recommend against it because you're just going to get a mistake somewhere and it's going to be a nightmare to code. So that's a for loop. This is saying I'm going to tell you to do something and I would just like you to do it. Let's have a look at a while loop. So this is a loop that will do something as long as the statement meets the requirement. So while loop requires true statement to be happening. It requires our initial statement to say, yes, this requirement is valid, therefore I will go through the loop. So a nice easy example of this is just iterating through integers. So if we say I equals 0, we'll just come up with a new variable called I, and we'll set it at 0. I'm going to say that while I is less than or equal to 5, I want you to conduct an action. I'm going to hit tab. Remember, we've got to have that indentation correct. I'm going to say that I want to print I equals, and then give it the value of I. Remember, we can do this with these brace marks as long as we are using an F string, that formatted string that we talked about in an earlier video, to make sure the syntax looks really nice. And we are going to print the value of I and then iterate I to be I plus 1. Now we can do this I plus equals 1, or we could type I equals I plus 1. The important thing is we are going to print and then we're going to increase the value of I by 1. Let's see what this looks like when we execute it. Here we see the bottom, I equals 0. That is our first value that we set I to be. And then it is incrementing one at a time until we get to this I equals 5, because our statement was for as long as I is less than or equal to 5, print out the value. As soon as, if we just go back down to our code, as soon as we have I equal to 5, it will print out I equals 5, add 1, I will equal 6, and we will go to that while statement to check whether or not we are still running on a true statement, and we will have the value of while I, being 6, is less than or equal to 5, print out the following statement. At that point, I is a value of 6. 6 is not less than or greater to 5, so therefore we are not printing out anything else. Now, similar to the for loop, we can put else statements into this as well. So we can just do a while loop with an else statement. And I can turn around and say while I equals 0, sorry, not while I equals 0, if I equals 0 to start with, while I is less than or equal to, let's go for 6 this time, print I equals the value of I, increment it by 1, and then I use the else statement to say that when we get to a point where this is no longer a valid part of the loop, I want you to print I is bigger than 6. So let's execute that to see what happens. We get a syntax error. Let's scroll down, see where I've made my mistake. Okay, really important we remember our syntax. Don't forget these colons when we're starting our loop. It happens to everybody, so just make sure that if you see these syntax errors that you go back and check your code. We can see that I've just simply forgotten the colon there. So now we've got our original loop, I being less than or equal to 5. So we get to 5, start again. Now this is our while with an else statement. I starts at 0, it increments up to 6 because on this secondary loop we've turned around and said that it should run through this for as long as I is less than or equal to 6. And then the else statement comes in with I is now bigger than 6. Let's just go back to the code so you can see why that's happened. And now we can turn around and say, this is what's going on. We're incrementing, and when that while statement is no longer valid, we are going to move to the else statement and print that out. We could go much further in depth when it comes to loops, but as an introduction, this is as far as we're going to go. Let's take a look at conditional statements and if statements. So what we mean by conditional statements are functions of a Python script that will only execute once prerequisite requirements have been met. So if we jump straight into our code, this is going to be much easier to understand. Let's create demo5.py and jump straight into it. We'll do a comment for conditional statement. One of the best ways to demonstrate this is to work with integers to start with. So let's set a couple of parameters, a couple of variables to be integer values. X will be 5, Y will be 10. If we turn around and say if Y is greater than X, print Y is bigger than X. And if we run this, we can see that this executes and we get 10 is bigger than 5. We have, let's jump back to the code, we've got our if statement to say if my value of Y is bigger than my value of X, print this command. And that's great. That means that we can turn around and make that if statement to say when this requirement is true, when this prerequisite is true, Y is greater than X, do this action. What happens if that's not true though? Well, we can turn around and use else if or elif in our coding to meet the other potential variations of true or false that might happen. So let's look at conditional statement with else if, which we type as elif in Python. So if I say x equals, let's jump that up to 50, y still equals 10. If y is greater than x, print y is bigger than x. Nice and simple. This time it will not print out because y is not bigger than x. Let's demonstrate that. Let's execute this. We can see we don't get any new line being printed out to the terminal. What we can do is we can use elif. If y is smaller than x, we can say y is smaller than x. And this way it will check our code and say, well, if y is bigger than x, print this, but if y is smaller than x, print this instead. Let's take a quick look what happens. We can see this time we get our printed out statement of y is smaller than x. And that's great, but what happens if both values are the same? If we've got x is 50 and y is 50, neither one of these statements will be correct. So what we can do is we can use an else statement where what we are doing is saying that if none of the above statements are true, then revert to whatever I'm putting here. So I can turn around and say, if y is bigger than x, print this line. if y is smaller than x, print this line. And if neither one of those statements are true, print this line. And if we save that, we can see that we get that else statement being provided. The variables meet that else statement, not the if, not the else if. They have to go down to that else statement. So this is a very trivial, simplistic way of looking at an if and that kind of conditional statement. But what happens when we want to explore this in a more detailed way? We've looked at in our previous script about having multiple parameters. Let's turn around and bring a function into this where we are checking multiple different true or false statements to see whether or not we can make a significantly complex conditional statement command. In cybersecurity, there are a lot of exams, a lot of tests that people have to do. Let's come up with a function called exam. And let's say that there is a practical aspect to an exam and a quiz that people have to do as part of some kind of development. We can use our if statement and say if the practical result is equal to a pass, so we're going to use a string integer for this one, and the quiz parameter has a result of lower than 60, so we're going to use an integer value here. So again, Python can understand what kinds of parameters we're using by the data we provide to it, so we can easily mix and match with this and do lots of different things and create lots of different complex statements depending on what we're trying to achieve. But if that is the situation we find ourselves in, one variable is set to pass and another variable has an integer value of lower than 60, then we can say print you passed the practical but failed the quiz. We can then use our else if, which we type as elif. So if our original if statement is not correct, we can say, well, if the practical was a result of a pass, and I just spotted a typo here, let's get that sorted before we execute this, and our quiz is greater or equal to 60, then we can print you passed the practical and the quiz. Well done. We then, when we're creating this, have to go through all the different potential combinations that we have to make sure that we're giving the correct output based on the input we receive. So we would then have else if, again that elif command, if the practical is a result of fail, and the quiz gets a result of greater or equal to 60, then we can print you failed the practical but passed the quiz. And then we can use that else statement that we mentioned earlier to say if any other combination of these, which would be a fail and something of less than 60, we could turn around and say print you failed both parts of the exam. Now, because we've set this up in a function, this gives us the ability to provide different parameter values to the exam function that will define what we get printed to the terminal. So if we run exam pass and 55, we should be able to trigger that first if statement of we passed the exam, passed the practical, but failed the quiz. So let's check whether or not we've got this working properly. Remember, syntax issues are incredibly important. We need to just make sure that we've got everything correct. You can see I've accidentally added a quotation mark. Even with all my notes, I can still make simple typos. So here we go. We can see that we're getting that statement to work. We can see we get the printed comment that we want. You've passed the practical, but failed the quiz. If we go back in here, we can see the different outputs that we can have. So we might have fail, but someone got 90% in a quiz. We might have that someone passed the practical and they got 75% in a quiz, and we might have that someone absolutely failed everything and had a terrible day. And if we run that, we can see all the different parts of that if and else if statement. So that's how we can use this conditional statement to figure out what part of our code is going to be executed. If we go back and have a quick look at that, the important thing to be aware of is the syntax of what you're doing. You've got to remember to make sure that if you are using strings, that's where your quotation marks are. If you're using integers, you are not wanting quotation marks. That was the error that you just saw. We've got to make sure that we have something happening on each of our different if and else if instances, even if that's not a print command, but it's just returning the information ready for something further on. That's absolutely fine. And that else statement at the end is used to catch all other potential variations of your parameters and anything that has not been included in your if and elif statements.